All right, guys. So let me just recap the parts of a circle with speed, right? So there's run, there's run. You get some time to finish the all the homework. Did you?
Yeah.
No, I didn't see a
I
Senate.
print out, I print everything and do it.
I didn't see a Senate, no.
Oh, that's no, hold on. I
Yeah.
answered it there. I just leave about 1 or 2 hours to show out it. So I say, why? I'll leave it out.
All right. Well, today we're gonna correct everything, right? So Ria, okay, wait, that's Simran. I didn't hear you for the whole time that I was here. That's concerning. Are you okay?
Yeah.
Okay, I'm glad to hear you okay. Right. All right. Somebody just sent a message in the Form 5 March chat saying class in progress. Kadisha, I feel like you was the lady for that. Go in the chat, send an Ian Allen sticker or something and be like class start. All right, so let me jump straight into it, right, guys? Straight into it. So Ria, you wasn't there for the last class. I'm going to be looking at you, right? And we're going to be looking at you, right? So do you know the parts of a circle, Ria? Parts of a circle.
The circumference, the radius,
Yeah, them kind of thing, right?
diameter. That's all I know.
So I want you to fill in the blanks here, right? Fill in the blanks here. So I am the distance all the way around the edge of a circle. What that sounding like? What does that sound like?
Circumference,
Yeah, that sounds like circumference. Second one. What does the second one sound like?
Get that one right. Really?
Say that again, that's wrong.
I can't get the first one right, really.
Big up yourself. Real. Real squared. Right? So Ria, I am the area inside the circle that is enclosed by a chord. Do you know what a chord is?
nope.
Yep, okay. If I were to draw a circle, right, and I were to connect 2 points, that's a chord. That's a chord.
Okay.
This is a chord. This is a chord, right? But you had to be able to distinguish between a chord and a diameter, right? This is a diameter, yeah,
Yeah.
right? I wouldn't call that a chord. So a chord is a line connecting 2 points, but it does not pass through the center. Yeah.
All
So
right.
so they're talking about that area enclosed by a chord. So like this. No, do you know what they call that?
Um.
You can play hangman.
No.
You can play some hangman. That's starting over with S, right? I want you to look at your options. Look at your options. Which one starting with S?
Sector, segment, second.
Yeah, sequence. That kind of sound like a short way of saying sukunya or something.
Ah, that's one way to put it.
Right. So secant, right? So you have three things. What do you think it looks like?
A sector,
No. It looked like it's part of a circle. It's like a part of a circle. But which one sound like part of something?
segment.
Yes, it's a segment, right? A segment. You have two types of segments, a major segment and a minor segment. This would be a minor segment, and this would be the major segment. Major is the bigger part, right?
Okay.
Right? So if anybody get anything wrong, tell me, right? So this one is segment.
I didn't get that one.
Nice. I am a straight line from the center of the circle to the edge. So you're going from the center to the edge. What that sound like?
A radius.
Video.
The radius. I am a line outside the circle which touches the circle at one point on the edge. So like they're talking about something like that.
A
Right?
tangent.
Right?
Tangent.
That's tangent. Mhm. I am a straight line starting at one point on the circle and ending at another point on the circle.
A chord?
Okay, yeah, that's our chord. Right, that's our chord. I am a straight line from one side of a circle to the other going through the center. Wait, I want Rhea to answer that. Rhea. So yeah, that's diameter.
Diameter.
I am a line outside the circle which passes through two different points of the circle, creating a chord.
Oh.
You might know this is called a secant.
You can't. Before I get that wrong.
Yes, it's like that. That's a secant. There's a secant. It's a secant. Although, so notice how it outside the circle, then the inside and the outside, and it passing through 2 points. That's secant, right? I am the area of a circle enclosed by two radii. Simran, what's that one? If here's an area enclosed by two radii, what's that? Simran, if you're talking, I can't tell you.
A sector.
Yeah. Mhm. Ria, did you know that?
Nope.
Let me show you what I'm talking about, right? So you have a circle here, you have maybe center point over here. This would be a radius. This would be a radius. And to have and wouldn't this be two radii?
Yeah.
And this would be a what? What I call this? It's piece of the circumference. That's what E. Yeah, that's when you see it. That's an arc.
Oh.
Piece of the circumference is called the arc. This is a radius, this is a radius. So you see this area over here. Call that that entire thing, I call that a sector. Yeah. Understand?
Yeah, makes sense.
So would this be a sector?
Yeah.
Yep, that would be a sector. Nice. Okay, would this be a sector, guys?
No.
No.
I want to hear some other opinions.
Oh. Ye-
Because Desron say no. I didn't know how to say no, you know.
Wait,
Yeah.
Desron, this is a sector, you know. Why? Because and this is a radius, and this is a radius,
Yes, yes.
Yeah.
and this is an arc. Yeah, that
Don't
is
you have a minor and a major sector? The two
uh
of them go be equal then.
yeah, two of them will be equal. Two of them will be equal in that instance. But that is
so,
Okay, okay.
only a sector. I
so,
know it is a semicircle, it is a semicircle, but it's also a sector. Yeah?
Okay.
so excuse.
Yeah? Tell me.
I was going to say it and you make it look like a diameter.
Wait, sir. Watch this, right? Watch this sky. This is our what? What's this?
A sector
Right? What if I make the angle on the inside bigger? Right? What's this?
is also a sector.
Okay. What's this?
A sector.
Yeah, you understand what I'm saying? It's a sector. What about this?
Yes, sir.
So a sector, right? Yeah.
So I was confused about that one again.
Nice. Right? Happy to understand that. So let me actually label our diagram now. So Ria, what would I call this?
A
So
second.
a secant, right?
Oh.
A secant. What would I call this?
Which one? Radius.
That's a radius. And what would I call G? Notice G is the area between two radius or two radii. What do I call that?
A sector?
Right, that's a sector. Uh-huh. What would I call H? H to go around. H
Circumference?
points.
Right? Yeah. Right? What about the B? What is B? Joshua.
That is the oh,
All right. Yeah, it's the diameter. Joshua, you answer C. Joshua, what is C?
C,
Yeah, what is C?
a chord.
Nice. Answer more one time. What is D? What is D? Tell me, Joshua, what is D?
D,
Yeah, what is D?
a segment.
All right. And while you're setting the place on fire, tell me what E is.
Tangent.
Nice. So I'm gonna assume everybody okay with a circle, right? Nice. And before I move on, let me just see if I remember what subtended means. Sky, I'm looking at you, eh? I'm looking at you. I remember from last class. Yes, having some trouble with subtended. Right, so Sky, if I have what I looking like, boy? That looking like 105. All right, so Sky, what subtends angle C?
So, A and B.
Yeah, length AB. Great. You remember. Big up yourself. Triangles worksheet now. I will run through this. Right. Jira, I'm not hearing you. I'm gonna call on you more. Right. So Jira, you're gonna help me figure out these triangle questions. Right. So Jira, before we continue, tell me if I add up all the angles in a triangle, what's supposed to get?
180 degrees.
Right. Now, Jira, how much kinds of triangles have like how much kinds of triangles are there? How much? Three, right? So if you have a triangle with no equal sides, what would you call that?
Scalene.
Right? Scaling. So some properties about scaling, you have no equal lengths and you have no equal angles. Okay. What if two of the angles are equal? What if two of the angles are equal? What would you call that?
Isosceles.
Isosceles, right? Another way to recognize an isosceles, you would look for these two lengths. Now, I mean these two lines on the lengths. Now, I noticed that some of you all had a hard time picking up on that. So while we on this, I'll go it over. So certain things you need to know about an isosceles triangle is isosceles, two lengths are equal. You need to know that. Two lengths are equal, yeah? Right? And you also need to know that the base angles are equal. Base angles are equal. So, Ria, on a scale to 1 to 10, how confused are you?
1.
1? Okay.
Yeah.
So you understand that an isosceles triangle, two of the lengths have to be the same, right?
Yep.
And how you just know which lengths is the same, Jada, is you just look for these lines here. Right, Jada? You look for them lines. And I will tell you which lines equal. Yeah. Right? Sky, Kadisha, Simran, everybody looking out for that. Ivan, you're looking out for where this dash is.
Yes, sir.
Right? So look, let me just try to confuse you guys. Intentional. Right? So there's run. If I say that these two lengths are equal, what two angles will be equal? Right? Let me just call this A, B, and C. So there's run. If I say that this side and this side are equal, then
B
what
and C.
A and C will be equal, right? So angle A will be equal to angle C. Anybody confused by that? Who here is confused by that? Who is confused by that? Kanisha,
Nobody, sir.
Ivan, you confused by that?
No,
No,
sir.
sir, I'm not confused.
Okay. All right. What if I do this? I hit all of this fast, you know why? And I say, well, I say this instead. What two angles would be equal? Kadisha, what two angles would be equal in that instance?
Y and Z.
Y and Z. Yes. Now, some of you all made a mistake when you was doing the questions. Some of you all would have said that X and Z is the same. But no. You're looking to see which sides are equal, and at the base of it, those angles will be equal. So I'm gonna try to tie up all here another time. Right, so Ria, if I draw this triangle here, right, and I say that those two sides equal, and I call this H, F, G, random letters. Can you tell me, Ria, which angles will be the same?
F and G.
Right. Is there anybody confused about that in class? Is there anybody that's confused about that?
Nah, sir.
Are you sure? I trust in all that, right? Putting trust in you guys. Right. So we went through scaling and isosceles. The last one we had to look at is equilateral. Now, in our equilateral triangles, you need to know that all of these sides are equal, and so are the lengths. Right? So you would generally see this, and this angle will be equal to this angle, which will be equal to this angle. Now, it only have one answer for equilateral triangle at the angle now. So let's run. If in an equilateral triangle, all of the angles are equal. Yeah, let's run. If I
Yeah.
say for equilateral
All
triangle,
the angles are 60.
exactly. Watch, because you would say 180 divided by 3, 60.
Yeah.
Right? You would never see an equilateral triangle with an angle other than 60. All the angles would always be 60. Pretty sure you think you could understand why?
You could repeat the question?
Pretty sure. I'm saying that in a equilateral triangle, each of the angles will always be 60. It can't be anything other than 60. You know why I'm saying that?
Yeah, because it in all it has to be 180. All angles add up to 180.
And all the angles in an equilateral triangle
180.
are equal.
Oh, right.
And so to be sure, all are equal, right? Right?
Okay.
And 180 would just be divided 3 times.
Yeah.
Yeah, so if all these angles are the same, I'll just divide 180 by 3.
Yeah. And then you get 60 each.
Yep. So
Right.
we're gonna go into the questions now. Right? First things first, what kind of triangle is this?
Isosceles.
Right, this is isosceles. So the question wanted us to figure out ABC. Now, Ria, does this notation confuse you?
Yes.
All right, let me show you a quick way to figure it out, right? Was he letter in the middle?
B.
Right, so we're talking about angle B. So angle B will be over here. Yeah.
Yeah.
Another way to think about it is ABC, right? So A, B, C. And the angle forming over here.
Yeah.
Right. So the way to figure out for angle B. So angle B will be what, guys? What do you think angle B will be?
40.
Yeah, 40. Right? So this is an isosceles triangle. Right? This is an isosceles triangle. And there's run. Why am I going to say that angle ABC is equal to 40 degrees? Tell me that's wrong.
Huh? Because all
So,
the base angles,
right, because
all the
base,
base angles are equal.
right, base angles in an isosceles triangle is there anybody in class that didn't understand this? Because I know some of you all didn't do this, eh? Some of you all did a bunch of working. You got tricked. Yeah. I don't understand how I figure out the answer. Sky, you good?
Yes, sir.
Yes, I did.
Ivan, you good?
Yes, sir.
Simran, Jada, Joshua, Perseus, Anna, are they good?
Yeah.
You're good. And if I ask you what angle C is, what angle C will be, guys? What do you think angle C would be?
100.
100, yes. Why? Somebody tell me why. Jada, why? So Jada, they're saying that angle C would be 100. You know why?
Because if you add angle A and angle B together and minus it from the total amount of degrees of angle A, B, and C, you'll get 100.
Bam. I feel you could take my job, boy. We,
Uh,
yeah, boy. Jada, start explaining now. I'll give you explanation. I'm sure certain now. All right. So Jada, question 2, right? They want me to find for angle BCA. What angle are they talking about? BCA. Which angle is this?
Angle C,
Angle C. So they want me to figure out for this. Now, first things first, what kind of triangle is this?
scalene.
Right. Are you seeing any lines? I'm not seeing any lines, any dashes. So, and just by looking at it, none of these sides are equal. So scaling, right? So, Jada, how would you find for angle C? Tell me, Jada, how would you find for angle C?
Add angle A and angle B together.
All right. So we do this in one shot. So angle BCA would be 180 degrees minus, in brackets, 90 plus 35. And what would that be equal to? So 90 plus 35 is 125. So that should be 45. 45?
I get 55.
I have 55 too.
Oh, yeah, that's correct. That's correct. Yeah, that's correct.
Yeah, so I get 55 as well.
Yeah, that's correct. Because 5 plus 2 is 7, 7, 5 is 10. Yeah, 80. Cool. 55 is the correct answer, right? And another reason why is because 55 plus 35 is 90. 90 plus 90 is 180. Yeah. All right. So 55 degrees. Is there anybody that doesn't understand how I did this? Tell me, guys. Is there anybody that didn't understand how I did this? Ria, are you confused?
Nope.
Nope. Okay. All right. Um, Simran, question 3. Do we have to do any working? Tell me, Simran, do we have to do any working at all?
No,
Nah. What's the answer?
60
60, right? Why? Because it's a what kind of triangle?
is an equilateral triangle.
Right. Equilateral. Right. All right. Question 4. In triangle ABC, find ACB. All right. So, Simran, while you're at it, they want us to figure out for what angle. What angle?
Um,
What's the letter in the middle? See? So they want us to find for angle C. So that's this angle, right? Yeah or no?
Yeah.
All right. And what kind of triangle is this?
Isosceles
Right? This is an isosceles triangle. How you know that?
is it have the two lines.
Right, the two dashes, right? So then if that is the case for you, if that is the case, Simran, what two angles should be the same?
C and B.
Right? C and B should be the same. So how would you find for C?
180 minus 48.
And we will do that next.
Yeah, you divide by 2.
Correct. So for anybody that's confused, right? If I take away 48 from 180, I'm going to get the remaining angles, right? And I know that those angles would be the same, so I can divide by 2 to find for 1. So angle ACB equal to 180 degrees minus 48 degrees all over 2. Anybody confused by that? Anybody? Guys? And she gets 66 degrees.
Yeah, I got 66.
Ria, it's confusing here.
Nope.
Joshua, this making sense?
No,
No, how come?
because therefore A and B, wait, no, hold on. Wait. But then if it have the signs there, the two signs, would that just mean that they equal because 66 there and 66 there? If that makes it, and also what doesn't make sense is that A is not even the top angle. C is.
Now, A is the top angle. And
But then
I know how it'll be confusing, right, Joshua? Let me show you something. So, Joshua, when we're looking at isosceles triangles, right? Check this, right? Check this. Wait. So, I feel like some of you would have made this mistake. Joshua, check this out. In this example here, right, Joshua, I have A, B, C. What would be the base angles over there, Joshua?
A and C.
Notice where they are. They are at the base of the equal sides. Yeah?
Yeah.
Joshua, what are the equal sides in this diagram?
66.
No, sides. Sides. So a side would be like AC, right, as a side. BC would be a side. So what sides are equal in this diagram? Now to figure out which
AC, AB.
AC and what?
AB.
Right. AC and AB because they have a dash, right?
Yes.
Right. Now, to figure out which angles will be equal, you're looking at the base for the equal sides. So in this diagram, these two sides will equal, so the base angles will be located at the base of the equal sides. So Joshua, check this out. This side equal here and this side equal. So wouldn't these angles be at the base of those equal sides?
Repeat that?
All right, so Joshua, notice that these two sides are equal, and so the base angle would be located at the base of the equal sides. So again, watch that, right? This side is equal to this side, yeah?
Yeah.
And so the base angles would be located at the base of the equal sides. So look at this diagram. What are the equal sides here, Joshua?
66.
Oh, 66 is our angle. The equal sides will be AC and AB. That confusing, yeah?
Yes.
Okay, so first things first, a side is actually a length, it's not an angle. You're confusing the angle with the side. So when I say side, I'm talking about like AC and AB. Those are sides. Now, how do you know which sides are equal? To figure that out, you're looking for dashes. So Joshua, and you seen a dash by length AC and you seen a dash by length AB? Yeah or no? Tell me, Joshua, are you seeing a dash here and a dash here?
Yes.
Yes. So if you're seeing a dash over there and over there, it means that this side and this side are equal. And if those sides are equal, then the base angle would have to be located between the base and the equal sides. Watch this, right? If I took this diagram, if I took this same diagram and I were to rotate it like this, I think you can see it now. Look at this, Joshua. And you understand that in this diagram, this and this will be the base angles, yeah?
Yeah.
If I rotate it, does the base angles change or it's still A and C?
It's still A and C.
Right, so watch. Look at this diagram and look at this diagram. Equal side here, base angle over here, and base angle over here. Equal side over here, equal side over here, base angle over here, and base angle over here. Yeah. If I were to take this diagram and draw it upright, you'd see it better. Watch. I could also draw that diagram as A, correct, it as A, C, B, and I think you'd be able to see it better now. You can see it better now if I took the diagram and I drew it up front, like upright.
Yes.
Yeah. So did anybody else get caught up with this question? Who here wasn't able to recognize that these were the base angles? Don't feel shame. Tell me,
Me,
Jada. It was
I
kind
made that same mistake
of
where I thought A and C were equal and not B and C.
right. So you get caught too. That's all right. That's all right. Anybody else get caught? Kadisha, did you get caught?
Yes, sir. I was confused.
All right. So
But I get it now.
I just want to go it over for anybody that might still be confused, right? Might still be confused. So like, check this out, right? So Joshua, you kind of understand this a little better now? A little better?
Yes.
All right. So Joshua, I know why you're confused, right? Because in all the diagrams, it is typically look like this, right? You would have this side and this side equal, and the base would quite literally be the base, right? Like all diagrams would be standing vertically upright. But in this diagram, it's a bit different. And Joshua, because in this diagram, it come like you took this and you rotated it. If I took this and I rotated it, and it kind of looks like the diagram I have on the screen now.
Yes.
Yeah, so is that diagram there, but you just rotate it. And so C and B are the base angles. Ria, on a scale to 1 to 10, how confused are you?
I could
You got
like one.
1. All right. Seven. Desron, you good?
Yes, sir.
Skirt. Desron. You know what I had to do? Before you leave my classes, I had to get like a soundboard with like all the sound effects and like play it in class.
I weak.
Real.
Really, yeah. I know Desron for a very long time, eh? This man has come up with some good sound effects. Desron is the man for these things. Yeah, and especially how I'm tired, I need the energy. Yeah, so Desron, use the sound effects. Okay, so have anybody that confused about this? Anybody at all? I take it as a no, right? And I think only what I kind of understand why I was kind of pointing at this at the start of class. And Jida, remember, Jida, at the start of the class, I kind of rotate the triangles and I was trying to see if I'll be able to recognize what angles would be equal. It's kind of like I build up to this one. So Jida, yeah, you fully understand this question now, right?
Yes, I do.
So let me test you, right? Let me test you. And Joshua testing you as well. So check this out, right, guys? Let me just say I have this triangle here. And I tell Ali that those two sides equal. I'm gonna call this X, I'm gonna call this Y, and I'm gonna call this Z. All right. And I tell Ali that this is 44 degrees. Could somebody tell me what X or Z is? So I give you only 1 minute for that. I want Ali to figure
So you
out.
just given us you 1 degree, you one,
Yes,
you one.
correct, Anna. I just given only one piece of information.
So
Try to figure out what X or Z.
Hold on, just making sure we're not using no set of rules, no cosine, we're not gonna nothing. We just trying to figure out what it is.
Correct. I just want you guys to figure out what X or Z is.
Alright, no problem.
First of all, though, Anna, what kind of triangle is that?
Whatever you asking me, um, hmm, I don't wanna be stupid and say a normal one.
Yep.
I carry on, man. I really know.
All right. So I got to run through this one more time. All right. So Anna, you see how we have a dash here and a dash here,
Yeah, that means both sides equal.
right? If both sides equal in a triangle, what do you call a triangle?
Isosceles.
Correct. So the isosceles triangle, both sides will be equal, two sides equal, and the base angles are
Always equal.
yeah. So Anna, do you know what the base angles will be in this triangle?
Um, um, X and Z.
Correct. X and Z. So the base angles are always equal, are always in between the chord side and the base. So X and Z will be equal. Joshua, did you get it? Or you understanding this time?
Understand.
All right, so Joshua, until I agree
The
with you,
answers now.
wait, Anna. So Joshua, until I agree that angle X and angle Z will be the same.
Yes.
Nice. Right? Yeah, so Anna, you was asking me something?
I was asking if we could give the answers now.
No. So Anna, add up all the angles in a triangle, what would you get?
180.
Right? So if I were to take away 44 from 180, wouldn't that leave me with the sum of the other two angles?
Yeah,
Right? And since it's an isosceles triangle, these angles are the same, right? So
yeah,
wouldn't the remaining angle just be divided by 2 to figure out what each of them are? Like some of them.
yeah.
All right, so let's take away 44 from 180. What's 180 minus 44? Yeah,
136.
right? And wouldn't that 136 be the remaining angles? All right? So that 136 is the sum of the remaining angles, and we know that the remaining angles are the same. So I could just divide 136 by,
2,
what's the answer?
68.
Right. So this is 68, and this is 68. Yeah. So Anna, you feeling good about that?
Yes, I'm
That
very
was
proud of
very
myself
easy.
right now.
Nice. Ivan, I see you were saying something. You good?
That
Ivan?
was easy, sir.
I'm not hearing you properly, Ivan. I'm not hearing you properly at all. You might have to type in the chat.
That was very easy.
You said that was very easy.
Yeah.
Okay, good. Once you can see that is an isosceles triangle, easy. Right, Jada, were you able to get the correct answer of 68?
Yes.
Big up you. All right, big up you. All right, so we're gonna move on now. With Simran, were you able to figure it out? Sky, Perseus,
Yes, sir.
nice. Perseus, are you confused? Is there anything you want me to go over?
No, I'm good.
Okay, nice. Let me do question 5 now. First of all, guys, what kind of triangle is question 5? What kind of triangle is that?
Scalene.
A scalene, yeah. Now, Anna, I want you to help me here, right? So, Anna, how much of the angles we know the length for? I mean, what's the length? How much of the angles we know,
2.
right? So, we're only missing one angle. We're missing angle ABC, right? Which is angle B. So, if I want to figure out the one missing angle, what do you think I'd have to do?
Um, add angle A and C and take it away from 180.
That's correct. It's going to be 180 degrees minus open bracket 30 plus 110. And that's going to be 180 minus 140, and you should get 40 degrees. All right, so that's what angle ABC is equal to.
So
Right, Kadisha, let me know if you're confused.
so
Kadisha?
No, sir, I'm not confused.
All right.
so
Ivan?
No, sir, I'm not confused. I understand.
Okay, good. Ivan, you there?
we could have just take away. Like add first, like add first and 110.
I hear I can't hear you. Gotta type in the chat. It's sounding real distorted. All right. Okay, so let's move on, right? Jada, we good?
Yes, we are.
Nice. Question 6 now, guys. Are we going to get fooled? Kind of triangle is question 7. Somebody tell me fast. What kind of triangle is that?
So isosceles.
So we didn't even have to do any working, right? We know it's an isosceles triangle. So therefore, angle ACB would have to be equal to 45 degrees. Why? Because base angles in an isosceles triangle are equal. Right. Base angles in an isosceles. Right. So there's that. Now, how much of you guys copy down the different circle theorems? Because I would have sent the circle theorems to copy down last session. How much of you guys copy down? Desron, did you copy down the circle theorems?
No.
Hey boy, Desron.
Mine printed. I print everything and stick it in my book.
Yeah, but when you write it, when you draw it, you just remember it better.
I'll take time and draw it. I'll take time and draw it.
Okay, good. Sky, be honest with me. Did you copy down the circle theorems? Was that a good bit?
Yes, sir. Copy down more.
Okay, good. Because if you did, we could kind of run like speed through today, kind of accelerate. Jada, did you get a chance to copy down the circle theorems?
No, I did not. But I
What?
have my notes in secondary school and I have all of them copied down.
Okay, well, that was good. That was good. Right? So here what? Let me move straight into the different circle theorems, right? Circle theorem time. All right. So let me get all the different circle theorems. All right. So, Ria, I'm gonna call you, right? So I want you to read the first circle theorem. Read the first one for me.
Angles in the same segment and standing on the same chord are always equal.
Let me try to understand what they're saying. First thing is first, right, Ria? What is the green line over here? What's this line called?
Segment.
Nah.
Oh.
It connects 2 points at the circumference together. What's that?
Chord.
A chord, right? Yeah, that's a chord. Now,
Okay.
what would I call this entire thing over here? As a what?
A segment.
Yeah, that's correct. Right, so Ria, that's a segment, right? Now, notice something, Ria. And this angle and this angle, both of them standing up on the same chord,
Yeah.
right? I want you to imagine these as legs, right? Like standing up on this chord, right? And imagine this as legs, standing up on the same chord. So once angles are in the same segment, and then on the same chord, they will equal. So that's the first theorem. So angles in the same segment and standing on the same chord are always equal.
Okay.
So let me just go through the example. It's just theorem one. So I'm going to draw a circle here. So somebody tell me fast, what would I call this red line over here?
One.
What do I call it?
Chord.
A chord, right? Nice. I'm going to draw two angles. So that's draw another one. Now, would the first theorem apply to this diagram?
No.
No, sir.
Tell me why. Tell me why, guys.
Because the second one not standing on the chord.
It's canonical, right? It would apply now. Next question. Uh, would this angle be equal to this angle? Let me hear, guys. Tell me. Yeah or no?
Yes, sir.
Yes, sir.
Nah.
Nah. Nah.
I'll be twice the amount, I think.
So no.
Nah, that's wrong. It wouldn't be twice the amount. You'd have to use quadrilateral rules there. But let me explain why. The theorem says it must be in the same segment. Yeah? It tell
Oh.
tell me if I'm lying, right? But in this segment, this is a major segment, this is a minor segment. Let me write
Yeah.
what the rule was, right? So the rule for this says that angles in the same segments standing on the same arc or chord are equal. All right. So this, yes, this works, right? If you have a situation like this, then this angle here and this angle over here will be the same. So Jira, tell me if you're with me so far, like you understand that, right?
Yes.
And I hear that voice crack. I hear that voice crack. Jada, you hear that voice crack?
I think so.
All right, so I give you another example, right? We have a chord here, AB. Now you'll notice that I wrote angles in the same segment standing on the same arc or chord are equal. Now I want you to understand something, right? This would be chord AB, or you could also say that this is arc AB, right? Both is fine. So Jada, first things first, aren't both of these angles, wait, give me a second, right? Yeah, Jada, as soon as you start seeing the screen again, tell me, right? Yeah, you see the screen?
No, it's still black.
Seeing it now?
No. I don't know if that's my Wi-Fi or
see it.
your thing just giving trouble.
But that's wrong. You seen it, Hans?
Yeah.
Anybody else seeing the screen?
Yes, I see it.
Okay, so I am going to leave and join back.
All right. Okay, so does everybody agree that this angle, I could probably call this C and I could probably call this D. So everybody can see that this angle and this angle standing on the same chord. But more importantly, they are in the same what? Somebody tell me they are in the same what?
Segment.
The same segment. Everybody seeing that? If you're confused by what I'm saying, tell me no. Sky, confused by what I'm saying?
No, sir.
Yeah? Okay. So this works, right? This works. But I'm gonna change up the diagram a little bit, and I want you to tell me if this would work. Don't worry, guys, I will send these notes immediately after class, right? I will send it. Don't worry. So, Sky, if I did something like this, now both of them standing on the same arc or chord, but are they in the same segments?
No, sir.
No. So this would be, so these angles would not be equal, right?
No.
So I'll give you a quick example. Maybe we could say that this is what, like 44 degrees, and this could be 44 degrees. Okay. Um, I could call this angle 67 degrees, and well, if that's the case, this could be 113. I'll go see the theorem I had to use later on. All right. So essentially, the rule doesn't apply for this one. And can somebody tell me why it doesn't apply? Why doesn't the rule apply? The angles are not in the
Same segment.
sky. Yeah, agree with that?
Yes, sir.
Right. Ria, on a scale of 1 to 10, are you confused?
3.
3. Okay. So, yeah, you understand that they must be standing on the same chord, right?
Yeah.
Now, a chord is a line that's connect 2 points along the circumference, right? Now, a chord does cut a circle into portions. So you have this portion and you have this portion, right? So you see this portion over here? That's a segment. This looking like the bigger segment or the smaller segment. So you have that and you also have this. Which one looking bigger?
The
First,
first one.
right? So I'd call this the major segment and I'd call this the minor. Now, are both of the angles in the same segment?
Yep.
Right? So the rule applies there. Are they in the same segment? No.
Nope.
No. So the rule does not apply. Understand?
Okay. Yeah.
Nice. Great. Second one. A line drawn from the center of a circle to the midpoint of a chord is perpendicular to the chord at 90 degrees. Perpendicular just means 90 degrees. That's all. Right, guys? That's all. This one hardly ever comes, but it's self-explanatory. I don't think it's that hard to understand. I'll give you an example real quick. Right, so let's just say you have a chord over here. And so they could like see this one and it makes sense. Are they seeing the screen or not? Like let me know if are seeing the screen.
Yes, sir.
Are they seeing like two and a circle?
Wait, no, sir. I still seeing the notes.
Boy, I don't know why this thing giving so much trouble. Today by itself was kind of troublesome. The amount of run around that traffic on the highway is crazy. Anybody from north side? Anybody from class on north side? Or like everybody in like central and south?
Sir, I from the east.
From the east? Well, that kind of far. That kind of far. That is far from south. Right? So this theorem basically says you if you have a chord, right? If you have a chord and you were to draw the radius, the point at which the quote unquote radius touches the chord, it forms a right angle to the chord. And everybody could see what I'm talking about. Like all they could see it visually, right? Tell me if all they see what I'm talking about. The right angle over here. All they see what I'm
Yeah.
talking. Okay. Nice. Okay, you see this one over here? This one is real come. Is real come very, very, very frequently. So Sky, I want you to read theorem 3.
It says the angle at the center of a circle is twice the angle at the circumference.
Right. Now they kind of leave out something, right? But for this theorem to work, it must be standing on the same arc of chord. So here what? I have the theorems here, but I go in my notes, I'm going to write the better theorems, right? I'm gonna write the better ones. All right. So Sky, let's check this out, right? So let's just say you had a chord over here. You had a chord. And you had a center point over here. Center. Okay. So Sky, and you see I have an angle in the center over here.
Yes, sir.
All right, you see an angle there. And if I were to do this, so I have an angle going to the center and I have an angle going to the what?
The
It
circumference.
correct. So this theorem says once you have angles standing on the same arc or chord, then the angle at the center will be 2 times the angle at the circumference. And you can see what I'm talking about because the further you stretch the angle and the smaller the angle will get. That makes sense?
Yes, sir.
And the distance from here to here is half the distance from here to here.
Yes, sir.
Yeah, so that's why we're saying that, this angle here will be half this angle. Right, so let me write the appropriate theorem. And let me just give all the example. So, Sky, how much degrees is looking like?
So I can say about 80 something.
Let me say 80, 86. Now, according to this theorem, if this is 86 degrees, how much this should be?
So like 66.
No, 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 no. Again, this theorem says that the angle at the center is 2 times the angle at the circumference. So if this is 86, then this angle would have to be half of 86. What's half of 86? Quick maths.
43.
43, right? So let me write down the theorem for this. Right? Right? So the angle, right, so angle maths. So, okay. So I'm going to change this thing up a bit, and I want you all to tell me if the theorem still holds. So I could probably call this AB, just label this, right? So just AB, that's O, and I could probably call this C. Right? So, Kadisha, let me just explain what happened in here, right, Kadisha? So, and you can see we have two angles, one going to the center and one going to the circumference. Yeah?
Yeah. Mm-hmm.
So what I'm saying is the angle at the center has to be two times the angle at the circumference. So if this is 86, how to be 40. If this is 43, this how to be 86. Am I right?
Sorry. You was kind of breaking up a little bit.
So I'm saying that the angle at the center has to be two times the angle at the circumference. So if this is 86, then this would have been 43. Okay, there, that's it. I'm breaking up it.
Yeah, you're breaking up.
Am I breaking up it? That's 20 to the rest of you guys.
Yes, you're breaking up.
What about now? Like real bad or
You're sounding better. Yeah.
all right, so Kadisha, I see now the angle at the center. We have an angle at the center here. The angle at the center has to be two times the angle at the circumference. So you see how we have a 43 at the circumference, and at the center it would have to be 86.
Right.
That's that theorem.
Okay.
So if it work though, the angles must be standing on the same chord, otherwise it wouldn't work. So let me give you an example where it wouldn't work. So check this, right, guys? So that's running there.
Here?
Yeah. You think the theorem will work over here?
No.
No. Why?
Oh, not on the same chord.
On the same chord. So this wouldn't work. Right? Yeah. So Ria, tell me if you understand this.
Yep.
All right. Nice. So let me just test everybody, right? Just test everybody. So I'm gonna draw a circle. Draw a circle here. All right. So I'm gonna test you all on what we learned so far. You know what? I'm not gonna use any different colors because CXC, not gonna use any different colors. Okay. All right. Let me call this let me just say that this is 60 degrees. Okay. All right. All right, so this is all the information I given out here. All right, let me just label the diagram better. So I could call this O, call this A, call this B, call this C, call this D. I want you all to find for angle C. So for one, I want you all to find for BCA, find for BCA. And for the other one, I want you all to find for angle DAB, and I want you all to find for DBA. Okay, all right. And I'm going to throw in something as well. I'm going to say that this triangle is an equilateral triangle. So with that being said, I want you all to figure out for angle COA. So like, if all you think all you need help for this question, let me know. But I don't think it's insane. It basically covers everything we learned thus far. Maybe we could do the first question together. Right? So who wants to do the first part with me? BCA.
Sammy.
All right, Ivan. So first of all, BCA, what angle are you talking about?
So there's an isosceles.
Wait, that's not what I mean. What angle are you talking about? So BCA, what's the letter in the middle?
O.
Nah, BCA, what's the letter in the middle?
Oh, C.
Right, so BCA, that means they're talking about angle C. They want us to find for angle C. So do you have any ideas as to how we would find for angle C?
We're going to minus
Nah, not
1,
minus.
6, minus,
Nah,
correct?
we don't use minus.
So add,
Nah, we're not.
so divide,
Now, like I said, it's the theorems that you'd have learned thus far. So far, only surely two theorems. Well, three, but the second one kind of irrelevant. So the theorems that you should mainly be focused on is one. So look at the diagram and see if you're seeing one, and see if you're seeing three. So now, Ivan, are you seeing theorem one or theorem three in the diagram? If anybody,
yes, sir.
if anybody else sees it, you could unmute and let me know if any of you guys see it as well. So theorem one and theorem three. That's my hint.
Yeah, I seen it.
You seen it as run?
Yeah.
All right. So Ivan, let me see if Desron could figure it out. So Desron, which theorem I think apply to figure out for BCA?
And you use one for that.
Yeah, could use one for that.
So it's on the same code.
Right. So for those who not seeing it, check this out. Check this out. Are you seeing what I'm talking about now?
Yes, sir.
Yeah. Ria, if Ria, tell me if this is if it's out of a line, eh? And I have this angle going to the circumference, right? And it's standing up on AB. And I have this angle going to the circumference and it's standing up on AB. And you see that?
Yeah.
Right? So again, I even watch that, right? So I have a chord AB. So on that chord, I have this angle going to the circumference. And I also have this angle C going to the circumference. Hence, I have two angles in the same segment standing on the same arc or chord, and so they will be equal. You guys see that? I know it's hard to see, right? But essentially, you had to use this theorem. You had to use this theorem. Anna, I feel like you're a little confused. I'm gonna run that back one more time. Kadisha, Anna, Timron, Joshua, Jira. Jira, you want to run that back one more time?
Yeah, so you can run it back.
Yeah, excuse.
Yeah. Somebody would say an excuse.
Yes, sir. I was confused, right? But then I realized it upside down, basically. But when I shift, I actually could see it from the past example.
Yeah, you can see it and watch. Check it out.
Nicey bottom, nicey code. Yeah, I seen it now.
I draw it like this because CXC not gonna be forgiven, CXC going under all kind of way. You gotta be ready to see it. Right. So somebody said they'd like me to run it back. So Jira, you there?
Yes.
All right, so Jira. Let me show you the theorem by itself first. So imagine I had this chord over here. You can probably call this chord AB. I could call that AB. If I have this angle going to the circumference here, and I have this other angle going to the circumference, would those two angles be equal?
Wait, repeat that?
All right, so Jira, if I have two angles standing on the same arc or chord, and both of them in the same segment, and they're touching the circumference, would they be equal?
Yes.
Yes.
I think so, yes.
That's this theorem over here. So give that theorem a read from Jira.
Angles in the same segment standing on the same arc or chord are equal.
All right. So first things first, what do I mean by segment? Enter chord just cut a circle into two different slices, pieces.
Correct.
So I have a major segment over here, and I have a minor segment over here. And both of these angles in the same segment,
Yes.
right? And are they standing on the same arc or chord?
Yes.
So they're equal, right? Right. Wait, I should add to this. Right, so angles in the same segment standing on the same arc or chord. Wait, angles. There's more to add. Right, so angles at the circumference angles at the circumference in the same segment standing on the same arc or chord are equal. So this is the full theorem with everything. Right? So Jada, again, you're seeing two angles. These angles go into the circumference and they're standing on the same arc or chord and in the same segment. Yeah? Are you
Yes.
are you seeing that over here as well?
Yes.
Yeah. Anna, tell me if you're seeing that as well. I have this chord over here, right? I have this angle here going to the circumference. I have this angle over here also standing on the same chord and going to the circumference. So enter according to the first theorem, they should be equal.
Yeah.
Yeah, aren't you seeing that?
Yes.
Joshua, you seeing that?
Yes, sir.
Nice. Simran, what about you? I have two angles and they're standing on the same chord, so they should be equal. Perseus. If you're confused, tell me, right? Sky, you seen it clear as day, right?
That's it.
Okay, good. Anybody want me to go it over? Let me know, guys. All right. So my question to you all, in this complicated diagram, are you all seeing two angles standing on the same chord? And if so, tell me the chord. So Anna, actually no, Jada, looking at the diagram, can you tell me what chord two angles are standing on? What chord are you seeing? Jada?
A to B?
A to B, yes. If you look at A to B, right? And you can see that we have an angle C standing on AB and and it going to the circumference. Check that again. And we have angle C standing upon AB. Yeah or no, Jada?
Yes.
And then we have angle D also standing upon AB.
Yes.
So that is the case. What is angle C?
60 degrees.
Yes. And that's it. So BCA is equal to 60 degrees. Is there anybody that don't understand that for the life of them? Ria, you understand that?
Yep.
Nice. And let me just write down the theorem one time. So angle angles at the circumference. Right, so the angles must be at the circumference, right? So angles at the circumference in the same segment, they must be in the same segment. In the same segment, right? And they must be standing on the same arc or chord. Standing on the same arc or chord.
And kilo, right?
Right. Arc or chord are equal, right? Right. So is there anybody, like guys, I don't shame anybody yet. If you still don't understand it, tell me. I'll go it over. Right? Is there anybody in class that doesn't see why um I'm saying BCA 60? Is there anybody that doesn't understand it? If you do understand it, tell me yeah. So I'm gonna to move on.
Yeah.
Yes.
Yeah, all right. Let's
Yeah.
move on to DAB now. So where is DAB? That's the question. DAB. So DAB, that would be this angle over here. So that's the next thing they want us to figure out. So that's Ron, I'm going to ask you for help with this one.
Yeah.
Right, so DAB, they are talking about,
About 60 degrees.
right, why are you saying that? Correct.
And where isosceles.
Yes. Jira, are you seeing what Desron is talking about with the isosceles?
Yes.
Right. Let's check this out, guys. If you notice in this triangle, it have a dash over here and have a dash over here. So that means this would also be 60. Excellent job. Right? Right, and Desron, what's the reason for that? Right, so DAB is equal to 60 degrees. What's the reason for that?
Reason is that all base angles,
And so base angles in on,
isosceles are equal.
right. Now, anything, I just hope I didn't spell isosceles on the exam there. I hope so. Imagine knowing the proper thing to write and then cast spell isosceles. It has happened to me before. Long time ago, but isosceles is a triple word.
But this is maths, not English.
That's true, eh? That's true. Fair point. Tell them you make a substitution with the letters. Yeah, tell them that. Right? Base angles in an isosceles triangle are equal. So is there anybody that don't understand why we saying that this is 60? If you do understand, tell me yeah, so I can move on.
Yes, sir.
Yeah, Sky, yeah. Kadisha, what about you? Simran?
Yes, sir.
Yeah, Joshua, right?
Yes, sir.
Nice. Ivan, Simran, Anna, very good.
Yes, sir.
Yeah.
Yes, sir.
Cool. Let me move on to DBE. Right? DBE. Where would that be? I'm gonna call somebody else. So Anna, I'm gonna call upon your help for this. So DBE. Do you agree that that would be over here?
Yeah.
Yeah. Let me see why. So DBE. So DBE. That would be the angle forming in the middle. So DBA is over there. Right? Now, first things first, Anna, what kind of triangle do we have? Did we have over here? What kind of triangle was that?
Isosceles.
All right. So we found what the base angles were. So we only missed one angle. So what's the next step?
180 take away 120.
How are you gonna get?
Huh?
What would you get if you do that?
No, next 60.
Yeah.
So all sides of the triangle equal.
Well, I come
Well,
up,
all angles.
I come up with this question. So I didn't draw the question to scale. I make a mistake when drawing the diagram, but we could figure it out, right? So this would also be equal to 60 degrees. And the reason why is because 180 minus 60 plus 60 is equal to 60 degrees, right? I'll give you a more mathematically correct question for homework, but like I'm tired right now. But I'll give you a good question. The main thing right now is that all you can see the theorems and rules you gotta apply to get the answer. So ignore the stupid diagram for now. For now, just once you can see how it does work, that's good. So, Anna, you understand part three, right? You go with that?
Yeah, the boss.
All right, nice. So 60 degrees. I'm gonna call somebody else now. So, Sky, I want you to help me with question four, right? Give me a color. Give me a color.
So you use pink already?
Yeah, just use pink.
So red.
Red. I used red already.
Green then.
Okay. All right. So COA. 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 Yeah. COA. How would I figure out that? So COA.
The answer is 120.
Yeah, the answer is 120. But like I drew the diagram real stupid, right? I drew the diagram kind of weird because all you notice that this is 60, and when you work it out, I mean, we see that this is an equilateral triangle, right? So it will also be 60, but that kind of paradoxical. Because if this is 60, but like I said, just don't bother with the diagram for now. The main thing is that you can see it. So, Sky, and you can see, and they said that this would be an isosceles triangle, I mean, an equilateral triangle. Just saw that. Check it out.
Yes, sir.
You see that? So this would be 60, this would be 60, and this would also be what? 60.
Yes, sir.
And if this angle at the circumference is 60, then the angle at the center would be what?
So twice the size.
Right? So what is twice? What is 60 times 2?
So 120.
Right. I'll give all a better question for homework. Right? But this question essentially combining everything you learn up to this point. Next class, we go finish up the theorems and start past paper questions. Yeah, this is a short topic. It's just the practices take real long. Right? So, Sky, could you tell me the full theorem I used? So I'm gonna start you off at the angle at B.
So that's not.
Here, we'll try to figure it out as we go along. So look at what we did. So we said that the angle at the circumference, or wait, if you do now, you gotta say half the angle at the center. That's fine, but the more standard one is saying that the angle at the center is, tell me, Sky, the angle at the center has to be 2 times what?
60 degrees.
When you're writing the theorem, you don't use values. You just be general. Right? So you would say the angle at the center is 2 times the angle at the. So if you look at this diagram, we had the angle at the circumference, right? And to figure out that, you had to multiply that by 2. Why? That's because anytime you have this condition, the angle at the center will be 2 times the angle at the circumference. So that's the theorem there. So the angle at the center is 2 times the angle at the circumference. And you need to add in that it must be standing up on the same arc of chord. Right?
Say him.
And now here, yeah.
Okay, so yeah.
Right, so let me know if you understand that.
Yes, I understand.
Nice. Right, so that's essentially it for today. And the next, I will send some homework. Right? Are they want tricky homework or like easy homework? So,
Nobody wanna trick you, man.
Anna, you want tricky homework?
Pardon?
You want tricky homework?
No.
No. But here what, right, Anna? You think CXC gonna think that? You think CXC gonna ask for like, they call it what tricky question?
No.
Nah, they're not gonna ask none of that. They're just gonna give all a question. So here what? I give all like a moderately tough question. Tough in the sense that I didn't go through all the theorems with you. But here what, right? We at a point, everybody knows the parts of a circle. Yeah? Anna, and you know all the parts of a circle now,
Yeah.
right? You know how the triangles just work inside the circle, you know everything. So since everybody understands all the parts of a circle, you should be able to read the theorems and try to understand it a bit. You should be able to see how it does work. So I'll give all some questions and I'll like it send me when you do the working, right? The questions going to be testing more than the 3 theorems you do today, right? But I mean the theorems right here. You know all the parts of a circle, so I don't see why it should be hard to figure it out. I think you all could do it. Right? The hardest theorem to understand is probably this one. The angle between the tangent and the side of the triangle is equal to the interior opposite angle. That's probably the hardest one. So like before I go, let me just show you that one like real fast. Right? So again, everybody know what tangent is. Everybody know what triangle is, right? So imagine I had a triangle inside of a circle. Imagine I had this, right? And imagine I had a tangent. Right? So Jada, I do anything here that was confusing? Or like you understand? And you know what a tangent?
Yes.
So nothing confusing here, right? And because I have a triangle and I have a tangent, obviously I would have an angle in the middle. So I would have an angle over there, right? And I would have I would have an angle over here as well. So that theorem basically says the angle, right? The angle between the tangent and the triangle is equal to the angle on the inside, but the opposite one. So like you see that green angle to the side there? That will be equal to this angle on the inside. And you see this purple angle over here? That will be equal to this angle on the inside. So how I show my students it, just think of it like an X. Think of it like an X. And you'll get through. That is the hardest, one of the hardest theorems to see. Right? So any questions I'm going to give you guys, the theorems that will come the most frequently, it's going to be this one. They love to bring 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 this one. This one sometime-ish, but they still bring it. And they like to bring this one. Right? So I will send the notes immediately. And I will send homework either sometime tonight or sometime early tomorrow. So yeah, guys. Anybody have any questions before I end class today?
Yes, excuse. You just post the class recording in the group chats or
Yes.
okay.
I just posted recordings. Or you can just check my YouTube channel. It should be there. Right? It should be there.
Okay, so thanks.
No problem. Right? Anybody else have any questions? Anybody confused about anything?
No, sir. I just watch over the recording.
All right. Not a problem. Well, guys, I hope all you have a blessed night. Thanks for coming. Oh, wow, look, my Apple Pencil on 1%. That's crazy. All right. So, yeah, guys, have a good night. Later, everybody.
Bye,
Yes.
sir.
Bye-bye.
Bye.